Okay, good morning. Thank for assisting to this presentation. In this presentation, we are going to show you our facilities in the Spanish National Center on Hydrogen for developing all the steps in hydrogen projects. Uh, Spanish National Center on Hydrogen is a public research organization which is supported for both our central government but also our regional government of Castilla-La Mancha. Recently, we received a very great amount of funds of European regional development funds of 10 million, and with that, we have created 13 laboratories which are open to the scientific and technical community of hydrogen for developing whichever step in a hydrogen project. For example, we have laboratories which are focused on developing special and customized test benches to develop alkaline electrolyzer or to develop PEM fuel cell, and we can create special test benches according to your requirements. We have also more advanced laboratories like our power electronics laboratory or our microgrid laboratory, which I am responsible, and I will explain with further details later on. We have also laboratories for basic steps in the developing of fuel cell or electrolyzer technologies, like our CFD simulation laboratory or the laboratory for material characterization. We have also a specific laboratory for solid oxide technology, and we have a laboratory dedicated to the manufacturing of special specific parts of the fuel cell and the electrolyzer. We have a specific laboratory for storage development and to create high power test benches for PEM fuel cell. We have a specific laboratory for transport application, where we have a vehicle that is open to integrate new powertrains configuration and also a specific workshop facility. We have a small house that can be used as a pilot plant for several applications, and we are developing our last laboratory that it is based on biotechnology hydrogen production. We have auxiliary facilities for prototype manufacturing, also building demonstrator, or we have both electric and hydrogen refueling station, which are at disposal of projects or requirement of our customers. Well, what concerns to the microgrids laboratory, we have a specific energy management system tools based on model predictive control and hybrid energy storage system. Our microgrids are based on 3 energy storage systems, ultracapacitor, batteries, and also hydrogen. And with that, we get a high energy density, but also high power density in our world energy storage system. And we have developed an advanced energy management system which minimize the degradation issues in each component of the energy storage system. Our energy management system is based on 3 hierarchical control levels. With that, we can schedule our microgrids or our energy system from long term to real-time issues. At the tertiary level, we use a sample time of 1 hour and a control horizon of days. Later on, our secondary level manage the time horizon of 1 second, and later on, our primary control level manage all related with power electronic devices. Here is our physical installation. In our physical installation, we can act in both parts, in the energy management system, but also in the power electronics devices. So we use mixed integral programming for the energy management system of the microgrid, but later on, all the power electronics of our microgrids are based on control platform, based on real-time digital simulators of Opal RT, so we can modify whichever algorithm in the power electronics. This control platform can be also replaced by twin embedded control platform based on DSP of Texas Instruments, and whichever component of the microgrid can be also emulated, just integrating in the power electronic control platform the model of, for example, a flywheel, a wind turbine. We can also emulate whichever casuistic related with power quality issues in our grid emulator that has a very advanced and powerful real-time digital simulator based on Opal 5600. With this emulator, we can even to emulate coupled to the microgrid a grid casuistic with 100 of nodes, for example. In our microgrids also, we can integrate specific and customized test bench of fuel cell or electrolyzer in order to test final use behavior of these devices. Here I show you several control algorithms that we have developed. For example, the day-ahead market application of our microgrid, where, as you see, the microgrid controller decide the best instant to sell or to buy energy from the main grid, but minimizes the peak current of the charging and discharging process in the batteries, but also minimizes the working hours of the electrolyzer and the fuel cell, as well as minimizes the power fluctuation in the electrolyzer and fuel cell. This is because we use advanced control algorithms based on model predictive control. Here you have experimental results of our secondary control level. In the tertiary level, we have done the schedule. Now we have to follow this schedule. The prediction of the renewable energy is different than what you can find in real time. So the power fluctuation have to be taken into account, But this, what you have contracted with the main grid, you have to follow. And as you see, independently of the renewable energy prediction, the contract achieved with the main grid is followed. Here, you see how the electrolyzer and the fuel cell try to follow this what have been scheduled, but the controller is intelligent enough to decide to modify the final set point for the fuel cell or the electrolyzer, but always taking into account the degradation criteria, minimizing the power fluctuation, and also the start and stop cycles. Here you have the batteries in the dashed line is the schedule, but the real scenario have been different. So, but nevertheless, the battery try to follow, but also following minimum degradation criteria. So we reduce the peak current for the charging and discharging process of the battery. Later on, as ultracapacitor have not degradation issues, they are maintained in an intermediate state of charge, but absorbing all the fluctuation in the remaining energy of the microgrid. Later on, the last level is the power electronic level, where we have also developed a control algorithm based on MPC controller. So before taking the control decision of which gate is going to be acted, we predict the best combination of gates, just a prediction, just making an equivalent thevenin of the impedance which is connected to the power inverter. So here you can see the difference between traditional control methods based on on integral PWM controller and our model predictive control methods. Just in one cycle of the fundamental frequency, the reference is reached. We have also similar controller for grid connected, and here you can find the comparison with our no transient response in the tracking of the reference in active and reactive power. Well, I have no more time, but we have advanced in energy management system applied to microgrids with energy management with energy storage system, and we have developed this control algorithm for network of microgrids for external agents which interact and require a determinate power profile to the microgrid when the price for recharging an electrical vehicle or to refuel an external fuel cell vehicle of the microgrid, and also for the application of convenient cooling, heating, and power microgrids. Well, this is all, and we will be glad if we cooperate with you, or all of our installations are open to the hydrogen community in terms of project proposal, final demonstrator, or if you require for us a determined service in our different laboratories, we will be glad to help to your company. Thanks.
Thank you, Dr. Félix Garcia Torres. Are there any questions from the audience right now? Okay, then let me have the first one. You talked about the algorithm. Is it also applicable to transportation applications?
Yes, you have only to think in the long term. In the case of transport, for example, if we apply it to a train, you have just to schedule the long term, all the journey, all the power and energy profile that you are going to require. You will make your schedule like your day ahead in the microgrid, and later on you will follow this schedule with our minimum degradation criteria, and later on you will act in a similar way with the power electronic devices.
Thank you very much. Further questions from the audience? Okay, if not, please go to the booth D741 in this direction to have further discussions. Thank you very much again.
Thank you.